Good evening, everyone. Welcome to our Zoom meeting, entitled the Research Data Management and Analysis. I have sent the Zoom background just in case you'd like to join us. We've recently visited Bohol and we are just in awe and captivated by the beauty of the Philippines. So, to start, let me introduce our speaker. And prior to the introduction of our speaker, let me tell you about MSU-TCTO. So MSU-TCTO, or Mindanao State University, Tawi-Tawi College of Oceanography and Technology. Its vision is to become a university in the Sulu Archipelago renowned for fisheries, marine, and environmental science and other discipline. Its mission is to fulfill its mandate that MSU-TCTO shall provide relevant quality education, especially to Muslims and other indigenous groups, promote environmental conservation and sustainable utilization of fisheries and marine resources, develop and transfer new knowledge and innovation technology to the community, and engage stakeholders in peace and socio-economic development endeavors. So, our speaker for today, he finished his fisheries degree at MSU-TCTO as well, which through RA 6060 was established on August 4, 1969. Initially, it was offering degree programs and diplomas in fisheries technology, um, but now it has become a university in the Sulu Archipelago renowned for, again, with its vision and mission, renowned for fisheries, marine, and environmental science and other disciplines. So during the 2008 licensure examination, our speaker, he placed first all over the Philippines. He also went to Japan as a part of JASU to conduct a proposal piece on research for his master's degree, which is a part of the University of the Philippines Visayas Master's Program. He got his doctorate degree from the same university and was a recipient of the DOS-TCTO Art Scholarship. And now he is one of the board members or board of directors of DOS-TCTO Art. After his PhD, he went back to his hometown, the Tawi-Tawi. Currently he is the Hatchery Manager and the MSU-TCTO Graduate Program Head. And our speaker for today is a Professor 6 of MSU-TCTO. He came back to share his experience and education to his fellow Tawi-Tawinians. And now, with the advent of technology, he aims to share everything to people beyond the island he is in. Ladies and gentlemen, Dr. Yashir Juma. Doc Yash? Okay. So currently, while Doc Yash is still going through some technological concerns, I'd like to acknowledge our participants. We have participants all over the Philippines for tonight's event. We have, of course, people from MSU-TCTO. We have registrants from BFAR, regions 9, 6, 7, and 8. We also have people from University of Antique Tario Lee Memorial Campus, Tibiao, Antique. Welcome, everyone. And of course, we have people from UP Visayas. We also have people from MSU Sulu, University of Eastern Philippines, Aklan State University, Zamboanga State College of Marine Sciences and Technology. We have people from Biso Kandihay Campus. We also have representatives from DOST Region 6. Welcome and good evening. We also have participants from MSU Lanao del Norte Agricultural College. And we have people from Bohol State University. Okay. Um, we hope that you enjoy and you learn a lot from this conference, no? Of course, I know that this is pretty much a distant setup, but to acknowledge your presence and to humanize our Zoom meeting, may we request everyone to send hearts or reactions or say good evening sa chat so we'll know that you're actually there and ready. All right, thank you. Thank you for the hearts. Thank you, everyone. And Doc Yash, are you ready? All right. So I'll give
Yes,
the floor now to Dr. Yashir Juma.
thank you. And good evening. Am I audible?
Yes, Doc Yash, loud and
Okay.
clear.
So now, as part of the process in my of my advices is that one of the training is on the data management and analysis. But of course, I would like to see someone here in the room so that because they are the priority, and I open it to all so that I could share to all of you how we do how I do on my advising. So with that, without further ado, let's delve into the research data management analysis. Although I'm not a statistician by profession, but of course, as a researcher, we have to equip with this knowledge in order for us at least because we are the one that will explain. We should know how our data being managed and of course being processed, being edited, and being analyzed, and interpreted, and of course for presentations and of course for publications. So with that, even we don't have that although we are not a statistician, but of course me as a PhD have been into undergrad statistic and of course my master's and my PhD. And now still I'm learning on the statistic aspect. So with that, um I would like to share to you my recent advancement on the data management and analysis. So before I proceed, I would like to acknowledge my my new mentor in this aspect, aside from my professor in my undergrad, master's, and PhD. So I met these two people, Dr. Ofe and Sir Vincent, and I'm part of the basic research method training on last November's 11 to 15 at Arnold Hotel, Convention, Cotabato City, as as we are called by BARM because last year I was the director for research. So with that, um, I would like to share to you some sort of re-echo or a recap or a re-echo seminar where they shared some aspect on the data management in analysis. And this as just some of the slide here is that I excerpt it from the slide of Sir Vincent Christians Pipito, assistant professor from Ateneo School of Medicine and Public Health. Of course, I'm in a fisheries. I'm in a field of fisheries, and I want to have this interdisciplinary research, which is I want to relate it to the health, so aquaculture and health, something like that. But of course, there is a different approach. So with this, what I learned is that this is coming from the health people. So I do hope that this is of course in general approach wherein I hope that everybody could relate this as we go on with our discussion. And the main actually our most highlighted activities tonight is we will we will we will try to operate the just. So with that, by the end of this topic, I'm expected the learning objectives such as describe the activities involved in data processing, and of course, discuss the different factors to be considered when determining the appropriate statistical tools to be applied in data analysis, explain the varied statistical tools that can be used in describing data and making inferences, and of course, you prepare dummy tables given the objective of the study. So what is data management? Of course, I just get this from the AI, the free AI, not the chat GPT. So first is that, of course, this is a general knowledge. You have to organize your data. I encountered students where they always have this problem in the data management. They lost the data, or their data was corrupted, so they could not no longer proceed with their MS, or they lost their data in a sense that their laptop gone missing or whatsoever. But of course, you have to, as a researcher, you have to organize your data, and of course, use your backup your data. For example, you send it in a Google Drive, and of course, via online, and properly document your data, properly label your data, and use data management software such as, for example, Excel or SPSS or maybe the JAST, and put a security on your if you have a high profile data. Another one is that data sharing. So if you have your collaboration, or if you are in tandem, or if you're in triplets in your study, you share your data. For example, if you have put it in a Google Drive and then let it share to your co-authors. Of course, you have to consider ethical considerations, especially when you are dealing with human subjects. So if to those who are into qualitative research, for example, or in social sciences, wherein they considered, for example, FISAFOC, you have to consider the ethical considerations. And of course, as part of your data management, you have to have a regular reviews of what you are doing in your data management so that you can have your improve some, it's this part of improvements on how you are going to manage your data. So let's delve immediately into the data analysis. So part of the data analysis that, of course, you have data processing. And there are two, no, when you are having the data processing, and that is editing and encoding. So what are the two phases? For example, right after the collection data, two pieces of editing data, right after data collections, but before data are coded. So when you try to code your data, for example, what is the code for the male or a female or something like that. And this space is usually done in the field right after the data is entered into the computer, but before the statistical outputs are generated. So those are the phases that you have to consider in editing your data. So here in the code, of course, after editing is the coding. And as part of the editing the data, involves inspection and correction of collected data when necessary. Of course, completeness of data collection instrument, values which are out of range, logical consistencies, comprehensibility, legibility, irrelevant responses. But there are some responses which is irrelevant actually. So like what I encountered in my high school is that out of this range 1 to 10, somebody gives 0. So that's irrelevant responses. And then coding data, transforming collected data into numeric or other symbols to facilitate cleaning and analysis. So of course, for example, later on you will see how this coding data being what you call that, especially when you are in a qualitative, you know, to try to put the numerical or a nominal or the nominal text. And the code should be exhaustive and mutually exclusive. So of course, to separate from the other codes or to distinguish it. Another one is that we have here the factors to be considered in data analysis. Of course, you have to consider the objective of the study. So especially the the specific objectives in your data analysis and the types of variables being analyzed. Of course, your study design. So if your study design is in randomizations or maybe into chi-square or whatsoever, but you have to at least anchor your data analysis on that. A number of variables included in the analysis. So you have to also consider the number of variables. And of course, the sample size. Sometimes we really have to look into the sample size in order for us at least to see how affirmative we are, or how concrete, how robust is your data is. Extends to which use or requirements for the valid applications of parametric tests are satisfied. I do hope that you can distinguish between parametric and non-parametric tests, because if you try to read the book of an introduction to statistics, is that you can encounter the non-parametric at the last of the chapter. So of course we are not statistician, but still we have to know that parametric and non-parametric counterpart. In later on we'll discuss how this non-parametric being used. So objective studies, these examples of how you anchored your analysis into the objective studies. Of course, for example, if your objective studies is that what is the mean birth weight of babies born to mother age, or what is the main birth weight of babies born to mother age 18 to 35, what is the mean birth weight of babies born to mother age 36 to 49, simply estimation of the remains. And is there a difference among the mean birth weight of babies born to mother age less than 18 to 35 and 36 to 49 years old at the time they give birth? So of course that involves estimation of three means or test of hypothesis among three means. So another one is there difference among the prevalence of the body weight, no? Among babies, low body weight babies born to mother age 18 or and so on. So this includes the test of hypothesis. But of course, if the objective is, for example, is body birth weight of the child treated with the age of the mother upon giving birth. So you can have the qualitative and the quantitative data using the chi-square, and of course applying the correlations analysis. Here we have the type of variables. So of course the variables. So what are the variables? These are independent variables. For example, independent variables, we have the nominal, the ordinal, the interval, the ratio. So the nominal always qualitative. Categories are simply labels and cannot be used or nor meaningful uh, for ranking. For example, the color, the red, the white, the blue, for example, the ordinal can be qualitative and or quantitative. Categories have an inherent or implied ranking system. So we have here quantitative categories to measure the order or rank rather than the actual value. And then the interval always quantitative and ratio always quantitative, but the difference, the exact difference between the categories can be measured, but the 0 point is arbitrary. And the ratio of one number over for the ratio has a fixed 0 point. So these are the type of variables. So what is this study design? So of course, if you are into fisheries, because we have the RCBD and the CRD, I don't know if you are using chi-square for the study design. But in here, since our training is on the basic research methods, particularly this year, the Philippine Council for Health Research and Development, they have this study science, the attribute, the cohort, the case control, and the cross-sectional. So you have this, the attribute, the cohort populations without the disease, for example, the case control populations with the disease cases, population without the disease control. And then the cross-sectionals, the populations with both disease and exposure status unknown at start of study. So these are the study designs that is being presented during our training by the fisher people. Now let's proceed with the number of variables. When one variable is analyzed, descriptive measures of central tendency, mean or median, invariability, standard deviation, and interquartile range are presented, histogram for quantitative data. So this, when we talk about the quantitative, we are always doing about the mean, the median, the parametric test. We are into this descriptive measures actually, especially the central tendency. When two variables are being studied, cross tabulations and class test of hypothesis or their non-parametric equivalence. So we have the parametric and non-parametric equivalent, depending if that is homogeneous or not, or normalized or not. When multiple variables are being studied, multivariate regression analysis. I'm not sure if you are using multivariate regressions, but so far, as far as my analysis is concerned, is that I'm not into I'm just into factorial experiment, 3 by 2 factorial, something like that. So sample, how about the sample size? How does it matter? For the sample size is that there are several statistical tools which can be valid applied only when the sample size is large. An example of this is the chi-test square when the sample size is too small. The valid application of this test, Fisher exact probability test, is used instead. Most tests designed for small sample are under the category of non-parametric test. So those are the things that you have to consider when you try to have the sample test. So in here, later on, you will, what do you call that? You will encounter how does the sample size really matter. So I think I have one note being presented by our speaker, wherein what's the difference between parametric and non-parametric. I just forgot that the keywords, because in non-parametric tests, they are not using the central tendency, but instead some sort of the distributions. Next. So extent to which some extent to which usual requirement for the valid application of parametric tests are satisfied. Some commonly used statistic tests, for example, the t-test, the z-test, analysis of variance, linear regressions are called parametric tests because they have assumptions to be met. For example, normality, independence, heteroscedasticity, or the skewness. Another one, please check if your data meets the assumptions or else use their non-parametric equivalence. So later on, I will present the parametric and non-parametric equivalence. How about the statistical inference? How does this being? So just imagine about the populations, and then you get the samples, and then you generalize it with a sample, with the population. So meaning you just get the portions, and then your inferences behave like a population. So that's this statistical inference. Of course, this your conclusions based on the samples, and then you generalize it with the population. So those are statistical inference. How about the hypothesis test? If we do analytical statistic or use analytical design, hypothesis tests are sometimes necessary for objectives that aim to establish effectiveness or association, or if we intend to estimate a population parameter and compare it with the standard. More formally, it is the assessment of the plausibility of a hypothesis given the collected data. And there are two hypotheses: the null, which is always statement of equality. So the null hypothesis, A, or the mean the mean sample is equal to the mean sample of B. A mean sample is always like that. And the alternative hypothesis, which is always a statement of a difference, so opposite, not equal. So if you have the basic statistics that you have always the two hypotheses, the null and the alternative hypothesis. Accept null hypothesis, reject accept or reject null hypothesis. Something like that that we encountered in our statistic. So what next is that what statistical test to use. For example, um, here to determine the profile of the respondent subject of the study. For example, to determine the socio-demographic profile of patients with uncontrolled diabetes, so you can have this the parametric and non-parametric frequency distribution, graph, histogram, or bar graphs. Of course, the histogram is later on. We'll try to show you using the just that when to proceed with your for example with your statistical analysis. You have to part of that is you have descriptive statistic, and then after that you will proceed with that called with your analysis. For example, one way or the t-test, um just showing that the histogram if it is normally distributed or not. And to estimate the magnitude or level of a certain parameter, the qualitative group variables, one group, two groups, quantitative variables. So these are, for example, to determine the prevalence of smoking among the high school students. And in here we have the parametric. Okay. So next, um, here, how about that to compare the level of parameters being studied with a pre-specified level? So to determine the prevalence of smoking among adolescents in Quezon City is the same as that of the national prevalence. So you have the z-test for a single proportion and binomial test for the non-parametric. So we have here the parametric and non-parametric test. So in here, the t-test, the Wilcoxon-Mann Whitney, and of course the one-way ANOVA, the Kroskal-Wallis. These are the counterparts. So here is that the simple regression and of course the multiple regression. Now let's proceed with what is the p-value. The p-value, statistical tests give out a p-value after analysis. The p-value is the probability of obtaining a test result as extreme as the observed result under the assumption that the result is observed if the null hypothesis is correct. So that we always encounter the p-value actually in our paper. And a p-value quantifies strength of evidence against the null hypothesis. So you can see that the high strength 0.05 or that's the lowest strength, of course, and 0.01 or 0.001. If the p-value is low, it is very unlikely to get the observed result if the null hypothesis is true. This means that there is strong evidence for rejecting the null hypothesis. The p-value is high, it is likely to get the observed result if the null hypothesis is true. This means that there is insufficient evidence to reject the null hypothesis. So in our statistic, we see that the p-value, if that is significant or not, if there's a significant or not. The p-value is only one piece of the evidence. You should show the p-value together with the point estimate and confidence interval because results could be statistically significant but not clinically significant. Also, beware of type 2 error, concluding that there is no significant effect when in fact there is. Avoid this by ensuring that you have computed for the appropriate sample size requirement, ensuring that your number of participants met the sample size requirement. So taking it together, writing the data management analysis, first that you have write by chronological describing what you will do. Include data management and cleaning procedure. And then ensure that your data analysis plan has enough data to allow it to be spatially replicated. Next is that for quantitative studies, list procedures for descriptive statistic first, then procedure for more complicated analysis, then most complicated analysis. So you arrange your analysis from the easy to the hard part. Not the hard part to the easiest part. For quantitative studies, do not just list a test, briefly explain what they are used for. For quantitative studies, do not forget to by level of significance procedure for handling missing data. So this is one of the examples. For example, the one of the PPTs was, I think he's the 2%. He's one of the 2% with scientists, 2%. No, just imagine. So that's why we are amazed. And this, according to Sir Pipito, of course, one of his of his what you call that publications, that this is how they what you call that, they do data management analysis. I will read it to you. Data quality checks, such as checks for duplicates and range checks, were performed on the data set prior to any analysis. Because in our statistical analysis, we just use, oh, the data was analyzed using ANOVA or using sort of like that. But we do not, we failed to explain how your data being managed and being analyzed. In general, we just, in which that is not repeatable at all, because some people could not, how you manage or how you clean the data or you edit the data, something like that. You fail to mention it in your paper, and that is not within the realms of the SMART. Quantitative variables, including age and monthly income, were recorded to allow the assessment of possible linear trends in the association between these variables and the outcome. Some categorical variables were recorded to ensure that each stratum would have sufficient number of observation. Maternal knowledge score was aggregated from 7 yes, no questions. Incorrect answers or don't know answers were coded. No, sorry, this is how they coded as incorrect and given a 0 score and 1 for its correct answer. Score range from 0 to 7, with higher score implying better maternal knowledge. Lastly, variables that may be correlated were combined, such as marital status of the mother and employment status of the partner. No observation removed at any point in the analysis to ensure that standard error can be computed correctly. So, further, actually, the exposure variables were cross-tabulated with each of the two outcomes variables, and the association of this exposure with its outcome variables were tested with the person. Test for categorical exposure, adjusted Wald test for normally distributed continuous variables, or Wilcoxon rank. Some tests for skewed continuous variables. So just imagine, they mention about for normal, the subject to the Wald test, and Wilcoxon for the skewed. So skewed, that's non-parametric already. The distribution of missing data was shown for each variables, but we're not including estimating the p-values. For each of this association, crowd odds ratios were estimated using sample logistic regressions for survey data. As part of screening multi-potential confounders, its probable confounders and the outcome variables were cross-tabulated with each of the exposure variable using similar statistical tests as described above. Prior to doing multivariate analysis, observation with missing data for any of the variables of interest were excluded from the data analysis. We use logistic regression methods for both early initiation of breastfeeding. Detailed of building the final models are presented. So that's how, including the level of significance of 0.05 was used in all analysis, and 95 confidence intervals were reported, data management, so it's carried out in Stata. So including of course, the software. So how about presenting the data? I just ran through the presenting the data. I will not delve much into presenting the data. Describe your study population first. Present your result based on your objectives. Present result of simple analysis first before complicated ones. Use table figures wisely. Don't repeat in the text what is already presented in the tables or figures. So let's make redundant. Presenting data using figures. Use bar graph for presenting categorical data that are not mutually exclusive. And then use compound bar graphs for presenting categorical data from Likert scales. This is most being used by the social scientists. Line graphs are usually used in presenting time trains. So this is what examples of preparing dummy tables, typical dummy for describing categorical study. I hope you are using you start using the preparing dummy tables, typical dummy tables for describing tennis variables, then preparing dummy tables, typical for cross tabulation, and then preparing dummy tables, typical dummy tables for describing regressions, and preparing dummy tables, typical dummy tables for describing continuous problem. So the main objective of today's activity, actually, before we come to an end, is that we will describe you the jazz. So it's 7:34. We still have enough time, but this for the sake of the students who really wanted to, to have their own analysis or interpretations. You can use jazz. Why jazz? So this is Jeffrey's amazing statistic program. The question is that why jazz? So just few months ago, this is just 0.18.3, but now it's already 0.19, the recent version or the latest version of the jazz. So this jazz actually is operated by the University of Amsterdam. And at the end of the day, you can donate. Of course, this is a free software, and this is mostly on the statistical. They show the statistic views actually. The difference between jazz and the SPSS is that the SPSS is you need to pay for CPSS. You have to subscribe for SPSS. And between our studio is that it's very difficult to learn our studio. I myself, I found it very difficult. Just for using the code or for entering it's more on the programming aspects. So while the jazz is really into the statistics. So if you try to see it actually, for example, this one is that I have this show here open. So I have here the data library, which is built in, and then you can scroll down the debug. So in some other statistics that actually is that I'm not sure if I'm not sure if for SPS is because SPS is when you try to use I only use SPS as crack, so which is illegal. so so here you can see the data is that you can have the data numerical or the nominal or so, but in here you can have the scale, the ordinal, the nominal. So for the scale you have this dependent and then ordinal and nominals the independent. So for example, for here is which is the what you call it, the you can change the level. For example, here you can change the what I like here is that you have the female and the male. And the ordinal, you can have it, you can also, this is the ordinal. So from 1 to 5. But what I'm trying to show here is that for the descriptive statistic, so you have here just simply the statistic here is that you can you can explore so many statistics here actually. So in here you can just whatever you're going to click here doesn't really destroy your analysis. So for example, if you are using, of course, the mean, and then you want to have this, you have this determine the skewness, the kurtosis, and you have here the basic plots, where you can see the distributions, and of course, so let's take a look. For example, this one is that you can have it as nominal, and then you don't have to change much on this, on the what you call that, on the label. But um in 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 the test you can have descriptive statistic, as I also told you that before you proceed with t-test, ANOVA and regressions. You really have to show the descriptive statistic. So the descriptive statistic is that showing that you just by the histogram, it will show you if that is normally distributed or not, and before you proceed. So in here actually is that, for example, if you are using ANOVA, and the ANOVA is that, um, for example, you have the here the what is being what is what is good in jazz is that this data is intended for this, while this one is intended for that, because they have this instructions, something like that. Or so you can just simply put it there. Or, hmm. So let's try a new one. For example, this one. So this is, let's try, I think we'll try to have it another, just for the sake of, showing or demonstrations, we'll try to have the ANOVA, for example. So in here, um, what I'm going to also to tell you is that this, if you have this Excel, you have to save it in that, um for example, uh, you have this, you have this data, for example, from the library, ANOVA. So in here you have the to open the data file. But the data file, if you are save it in Excel, you cannot immediately open it in this, what you call that, in this JAS. You have to save it in CSV file. For example, this one, for example. So this one actually is this already in a CSV file. So for example, if you are going to open the file in the computer, for example. So let's take a look about the Excel file, for example. Let's put it in, let's say, we open too much. For example, the Excel. Let's open an Excel. For example, this one. So you have here, for example, the treatments. So you have here 1, 2, 3, 4, 5, for example. And you have this length, example. And you have this weight.
For a while. Love, I think you're showing a different screen. Um, yung sa Zoom mo ba?
Okay.
Change lang yung settings.
Okay.
Kasi yung nakikita namin yung PowerPoint yan.
So, ito lang.
Ito, book one Excel. You're doing
Okay.
Excel. Okay.
Okay.
Alright, sige.
Share.
Double
Okay.
check.
Hindi
Okay.
po gumagalaw yung ano, Doc,
Okay. So, let's have a length
slides.
and weight. So, usually, we're going to have it, let's say, save us, um, in this PC, for example. So, in here, you want to save it, you really have to look for the CSV, not comma deleted, but I think, CSV file, that file, CSV comma deleted. I think this one, save. Yeah, I see it. Where is that? Okay. So in that way, for example, what happened?
You're sharing ended. Kasi
Ah.
you close the file. Okay.
Yeah.
Not this one?
Yeah. Okay, anyway. I would like to share again I would like to open the JAS. For example, this one.
Yeah.
This one. Okay, share.
This one.
So now let's open the file, for example. So computer, desktop, and then where's that file? Here. So we can open we can open that file. But if your file is if your file is, for example, that you don't save that in the CSV, what will look like is that, for example, this one, um, so if you try to open it in just, what will going to show, what you will see is that, for example, you open using this. So you cannot open it. Actually, the file that you can open is that the CSV file. You have to convert it, or you have to save it as a CSV file. And for opening the file, you can have it from the recent files, or from even in the SPSS file, you can open it here. And you can also, if you have I don't know if some of you have this access on the OSF. So we have the database, we have the data library. So you can explore much on this, because what I can see on the JAS is that it's more on, really, if you're it's more on the statistic part. It's not like the R Studio that you really look for the code or the formula that it's more on programming. So of course the space is good, but unfortunately, if you don't have the subscriptions, it's very hard for you to, at the end of the day, for you, if you're going to cite, because we need to cite actually the software that we are using, especially if you have many version. For example, what particular version that you are using, and then if someone ask for a SPSS, if somebody will ask you that, or if the reviewer will ask you what is the license that of your SPSS. So it's very questionable if you are just using FRAC, because in that's one thing that I encountered in SPSS. That's why I really found just a very, you know, um user friendly, and of course it's very active, because every now and then it's updating. And I've seen that the most of the feature here is being updated from time to time. And just few months back, it just 0.18.3, and now it's 0.19.3. So you can find here uh, how you organize the data within the JAST. And um you can you can you can put in Excel and save it in a CSV file, and then open it in this in the JAST, and immediately you can analyze. So in this, you can run through or open the data in a database, wherein there is a list of the example here where you can access. For example, the t-test, you have this already, the JAST file, and of course the CSV file. So, and there are so many tutorial actually on the YouTube on how you use the, what you call the JAST. And I would like to end the presentation now, because I would like to entertain more questions from you, so that if I could not answer the questions, I will what you call that I will help you on on I will research for you guys. And of course, I really wanted to explore more on for example, the multi-regressions, something like that, and the chi-square, because what we are using in the physics is more on limited on the RCVD, the CRD, uh, statistical design, something like that. And on the parametric side and non-parametric side, when to use the parametric and when not to use parametric. So I think I would like to to end my presentations on that because it's already 7:49 and I would like to entertain questions.
All right. To our audience, to the people with us in the Zoom room, if you have questions, you can just raise your hand or send it via chat. But I'll also be reading your questions that you've sent during the registration. Doc Yash, can you please end your share screen so everybody can see everything? Charot. All right. But before we go on with the with the tawag dito, with the questions, maybe request everyone to please turn on their camera so we can take the photo documentation first, 'di ba? Para habang nag-iisip pa kayo ng questions, we get to document the photos muna. Okay, so we get to see your beautiful faces man. I know na you took your time in preparing man for tonight. Sige. Take your time, guys.
Before I would like also to request that two particular Khadija and Kisai Nasrit to remain after the Zoom, to remain in the room.
Oh no, charot. I'd like to acknowledge we have with us the president of Fishery Student Organization.
Yes, yes.
Yes, it's Rosalina. Hi, Rose. She's very active. Thank you for joining us tonight.
Good evening po.
Yan, good
Good
evening.
evening.
Happy New Year pala,
Good evening.
everyone.
Mag-download na kayo ng ng Jazz, ha?
Yes po.
Yes.
Yung latest version.
All right, I'll take a photo. Everyone, please smile. Okay, in 5, 4, 3, 2, 1, smile. Okay, I'll take another photo. 1, 2, 3, 4, 5. Again, parang hindi na ready si Mimi. All right. Waki, 1, 2, 3, go. Yeah. Okay, perfect. Thank you, everyone. Thank you. Okay, for the questions, I have here Doc Yash. The first request or question for the speaker, hopefully you can share a website, software, or an app for data management. I believe you've talked about JASP, which is a free statistical tool. Unlike SPSS could cost thousands, if not hundreds of thousands, if I'm correct. Kasi there's a license, and if an institution actually purchases an SPS, it could get super pricey. So JASP is our friend. No, but is there a management tool that you'd like to recommend?
Yeah, the Jazz. I have told you that the Jazz is that you can just download it freely from the web. So although they are asking about the donations, but you don't have to donate because we are in a country where
Donation's optional. What if you could donate?
optional. So you can download immediately and have it. If you are using Mac or using Windows, just find it because the recent now I just downloaded recently. I mean, just few minutes ago, I downloaded it 0.19.3, but the one that I'm using before with my student was 18.3. So just last year is 18. So I think it's already they have already 10 versions since from then. So with that, and I have seen that how they added some features with that. You can see even in their databases that they have this different. They uploaded some data or some attachment strings to that. So they are improving even on the. They are adding even more post hoc analysis and some of the features for were in not even SPSS has. They have. So because there is a team really maintaining this software. So you can now I'm encouraging you to use Just because Just is not a questionable because that is free. While unlike other software is that, for example, RStudio, of course, challenging for RStudio if you know how to use RStudio, it's good. But for me, I found it very difficult because it's time consuming to really even to understand how that it's more on you are into looking some case, looking some, mostly it's like programming for me. So I find it very difficult.
All right. Thank you, Doc Yash. By the way, I've sent the evaluation form, and please make sure that your names are spelled correctly for the certificates. Another question, Doc Yash, which post hoc analysis is best to be used? Is it Duncan or Turkey?
I'm in this just there is no DMRT. I think this only the 2K or the students. I'm a 2K test, 2K test. But of course, that's depending on the number of the samples.
Mm-mm.
I think they're both good, DMRT and 2K. There is, but in the just this there is still limited number of
Am
post
I
hoc.
pronouncing it wrong? It's pronounced Turkey.
2K test,
Ah,
not 4K. 2K test.
all right.
So I think that the 2K, yeah, it's still because there is of course the post hoc is that after you have found its significance for example for the t-test you don't have to stay because there's only two variables. But for one way or the two way, so there's significance to determine the specific differences among the treatments, and that's you go for the post hoc. And with that, you can just in the adjust you can just click the post hoc, go for post hoc, and click for that 2K. So
Mm,
that's how.
okay. There's another question. I think this question is more on ethics now. How to assure that the data given in a research is valid or not?
Valid or not. I think because the data is from you take it from the populations. So you have I have presented statistical inferences thinking that they are normal distributed. So meaning they behave like a normal distributions. Meaning if you try to see the distribution is like in bell, something like that. So but there are some samples, it depends on the number of your samples wherein it's skewed. And that's why it comes the parametric test, non-parametric test. So depending on the validity of your data, when to use the parametric and non-parametric test. So in here is that as long as, for example, you are into the number sample size. So sample size, the better is more than 30, something like that. So the lower the samples, that the weak your inferences or your claims for taking from from the populations. Because if the population is 1 million and you only get few, what do you expect? Something like that. So the more samples from the populations, the better. So with that, you can say that if that's why you have to test the normality, you have to test the homogeneity, you something like that before you proceed with your analysis. That's to really validate that your test is within that appropriate analysis. And that's why we are exploring the non-parametric. If your data is not normalized or not homogenized or not normally distributed, something like that.
All right. Thank you, Doc Yash. I'd like to add on that, no? Doc Yash explains things on a complicated manner because he has complicated ways of thinking. But as how I understand it, no, a sample is what represents the entire population. So it becomes valid if the distribution is in a perfect bell curve. That is in with regard to computations. If it represents the population as it is, let's say for example, your target data is that of mga high school or teenagers. So if there is a proportionately 30% of the population constitutes teenagers, your sample should be sufficient enough to represent that entire population. 'Di ba? Parang ganon. And also, with regard to ethics, I think in a way his question with regard to validity of the data na how can we ensure that the data was, kumbaga, nakuha siya in a legal or proper way at hindi siya gawa-gawa, parang ganon.
Oh,
I
yeah,
think there's
parang
no
that
way of
that
telling
also includes
unless
the
it's
randomization, yung mga non-biases, to remove non-biases. I
mm-mm.
think that's one thing that we wanted to point out or to pinpoint about the obtaining the data on how you're going to randomize or randomize getting the data, because you do not want just to get the data from the That's why it includes randomization. That's how your statistical designs comes in.
In social studies, we do case studies that although we have smaller sample size, but it's the amount of data that's too kumbaga, there's more data than population, and these case studies are phenomenological studies and the like, no, they provide a different kind of data. Yung camera ko, it's giving AI. Charot, wait lang. Another question, Doc Yash. As a first-year student of this field, what do we expect to learn and gain in the next 5 years? Oh my God, we're general. Okay, in the next 5 years.
I think as early as now, you really have to see where are you going. So, for example, somebody is, in among the siblings, somebody is looking into the elder, wherein someday you would like to become like them. For example, me, I'm under the mentor of two scientists, which is the UP Scientist 3. So I'm looking up into them. So for example, like what I presented, Sir Vincent, no Vincent or Pipito, is that he is just one of the 2%. Imagine 2% top scientists. So I think we are in a fisheries. We are molding you to become fisheries scientists. So where are you going? Is it for you to become entrepreneur or to become scientist or to become researcher or to become just see your elder and try. For example, when somebody talk to me and tell me what to do, I'm just asking them, I'm just trying to ask myself, where are you at your 35? So when you are at your 35 is Professor 6, maybe that's good. But when you are at your 45 is still assistant prof and you're telling me what to do. So something like that. What I'm telling you is that I'm not degrading anybody. But of course, you really have to look when what kind of person do you want to be? Something like that. So that's is in your first year, because in this later in their career after 30 years, 40 years, they realize that they want to do this. It's too late. You have to realize as early as first year what you are going to want. What do you want? Is it to publish more? So that because publish more is that there's a lot of money. You have the main author as money, and then prorate as, and then prices. So would you like to become one of the leading author in TCTO so that you have this MacBook or whatsoever you want? So because our school, the TCTO is giving the Pro Max iPhone, aside from the main author. There are so many incentives. So if you want to become a researcher and you want to publish more, look into the people that really publish more. But if you want to become Professor 6 that is receiving
All
almost
right.
20,000 a month, look for Professor 6. So that's your pattern on what they did. Something
So
like that.
So basically, as a first year, as a freshie of fisheries, you will expect to see and realize the importance of fisheries and cultivating and culturing more fish, because it is mostly focused on food security as well as, of course, the biodiversity of our environment, man. Because biodiversity is very important. It keeps everything in balance and in place. Thank you, Doc Yash, no, for that answer. Another question, how crucial is research data management? It's from MSU Lanao del Norte.
Yeah, I think as a professor, because the moment I handle you as my advisee, I always emphasize the data management. Data management, how you get your data and how you transfer the data, how you secure the data, you put it somewhere else. You just not leave it in your notebook and then your notebook you lose your notebook. It's not like that. Or you put in your laptop and then your laptop corrupt, and then you lost your laptop, you lost your data. It's not like that. So I always emphasize this because at the end of the semester, somebody will tell me that they lost the data, their laptop got virus, so that's why they lost. So that's why they could not submit. So that's why I really emphasize a simple steps in managing the data, wherein you have to need a backup. The moment you get your data, the moment you get that, you have to take photos. Aside from writing it, take photos and upload it immediately. Send it to your email, because the email is not being unless you forgot your password, but still you can recover, and then or put it in a Google Drive, because in every private email or your personal email, you can have your 15 gigabytes. So, and then share it to your trusted one, so that at the end of the day, your data is secured. Because I encountered individuals that was not able to finish her master's because the data was corrupted. So that's why you really have, it's a crucial step. Simple as that, it will it will lead you to lose your your ambition. It's very hard. So if you do some experiment, for example, some you're doing endangered species, and then you are only limited. You have limited samples, and then you lose that data. What will happen? Can you get the ludum as easy as that, like that? Oh, it's not like that. That's why the moment you get data, secure it immediately, put it somewhere else, and then back up, arrange it immediately. The moment, that's why I really emphasize the data management, because simple as that, but the very crucial. I hope I answered the questions.
Thank you, Doc Yash. I'd also like to add, no, having studied and did research myself, having a research data management could make your life so much easier, you guys. If your data is quite organized, you don't have to waste time in searching for your data and looking and kumbaga extracting matters from your, like, I know you could have thousands of data on hand from doing one single study. So having your data in place, it's like putting your ducks in a row and will make your life so much easier. Wala lang. I just like to add some razzle dazzle on your answer, Doc Yash. Thank you so much. There are other questions. What is the best method to use in comparing variables?
Yeah, in comparing variables, of course, it depends, because, for example, if you have t-test, the three variables, that one way, and of course, we have the, what you call that, the two-way ANOVA, and then we have the PCA, principal component analysis. So as we go on with that, so it depend on the objectives of your study, wherein you are going to compare your variables, because some is, descriptive statistics is enough. Some studies, some need a robust analysis and detailed analysis. Some it is still, no, because in some other university, they are encouraged to do a simple study, just comparisons, or just a t-test will do. But some others make it complicated, wherein even my undergrad, I use the two-way, so 2 by 2 factorial. And when I reach my master's, I used 2 by 3 factorial. So that's why I was able to explore more on the factorial experiment. And then I really wanted to do the principal component analysis, and the multi-parametric test. So with that, it's at the end of the day, it's how you complicate things on your part. Some says that, for example, about the, what you call that, the regressions, or the regressions is, you need to have more factors for the regressions analysis. But in here, actually, when I went to Kagoshima, is that their study, even in their PhD, they just use the t-test. So do not complicate things as early as, because I would like to explain to you that if there, for example, the principal component or the multi-parametric, or the factorial. So, for example, if they don't have the significance for the 2 by 2 the factorial experiment, that two-way ANOVA, you can do one-way ANOVA. And if there's no significance, you can have the t-test. So what I'm telling you is that still, if you have a very factorial experiment you can still break down into that. It depends on you. And the good thing is that what is good in a factorial experiment is that you can still chop it into pieces. That's what I'm doing in experiment. But when I talking about my dissertations, I just have these two tests having the transgenomics analysis of the control in the treated one. So when I went up, the more simply it became. But in my undergrad, it's factorial. When I do my dissertations, it's only the comparisons of treated and non-treated. That is only t-test.
Treated and non-treated, there's no other degrees with regard to, let's say, for example, 20%, 30%.
Yeah, but I think that is the proper transcriptomic because even though for example, the transcriptomic is that you drink one barrel, it's just the same with drinking one spoon. So why wasting your money with comparing the one spoon with one barrel when in fact your objective is just to determine the expressions express or not express.
All right. I have nothing against that claim.
Okay.
Another question. I really like this question. Very easy, very direct to the point, Doc Yash. How to do research data easily?
How to do research data easy.
Yeah.
Okay. You I want you to explore, in a JAS, you open the database, but there is a OSF, the online. That online, actually, there are some researchers that's just putting their data there. So accessing to that, you don't need to do research. You just get their data and analyze it and take your own research. So if you do not want to expose yourselves into, for example, into the field or into the spectrum or into the radiations or into the stress, what you just data mining, data science, you just mine the data from the online and get, for example, you want to compare the one sample t-test. So you compare the sample here with the other country, and that is through what you call that, through the online. So it's always possible nowadays to get data from wherever because there is a research, there is a publications that is intended for, I forgot that, but they publish only the data. It's your data, you can publish it, and if you know to mine that data, you don't have that because there are a lot of famous scientists that doesn't go to laboratory or doesn't go to the field. What they get is that they just get this software, they just get this modeling analysis, and they publish.
So basically, given the tantamount data that is available on the internet, you can do analysis with regard
You
to
can do analysis, yeah.
certain datas that were gathered by other people. And that's quite very common
Yes.
in math students, for example, in UP Visayas, and then they would
The one that published more is the one that gathered that mined the data from the internet.
correct.
For us, it takes, for example, a year, and then after that you publish. You find out this one, and then you wait if your organisms doesn't meet the survivors, what happens. But some other people actually you just get the data from the internet, and then so that's how the data science or data mining whatsoever. There's another field for that, but in fisheries we can still look for into it.
Okay. All right, Doc Yash, we have another question. This question was sent to me privately. This is from a student or a person under University of Antique, College of Fisheries. Good evening, everyone. My question is, how can research data remain relevant and applicable over time, where in particular topics, particularly for topics with limited annual publications and evolving statistical methods?
I think that is the relevant of data, isn't it?
No, yes, the question is on the relevance of data, given that
Yeah. So the relevance of data, for example, if you're going to compare the trend last 10 years ago with this year, So even last 10 years, it's still relevant because you want to compare, di ba?
Or
Last
you
100
may
years
compare.
ago, you want to mine. There is, I met these paleontologists, people, they compare the data that is happening through geologic that is happening thousands years ago. So I'm not, it's my point of view, how relevant is your data. But of course, if you are, it depends. If you are into geologists, wherein the, or they wanted to know if the present climate or weather or climate happens last 1,000 years ago. You want to compare. So it, when was the data become available? But still, we wanted to make a model that reflects data, some sort that happened last 10 years ago, 10,000 years ago, for example. So depends. For example, now is that COVID. The COVID is that, of course, if because of this, pandemic, we don't have that data, so everybody wanted to generate more data. So it still depends, isn't it? So still, what I'm telling you is that it depends on the objectives. Sometimes it depends on the trend, wherein if the trend is immune stimulant and then all the data is immune stimulants, and then if you, for example, the ISP from the PICARD or the DOST. So that's the trend. So they wanted to find your research if they research within their ISP, something like that. So it's still, and it's depend on the council, for example, on the DOST. So on an individual note, actually, it's still depending on the relevance on your part, wherein you can you can still considered if it is relevant or not, depending on the situations. For example, now is elections, so the data on the elections, who is the first, is really matter most. If you know, Tulpu is the second, yeah, we wanted to know because that's what the people wanted, isn't it? The pulse. So it depend. It's still depend. I hope I have you got my point on having the relevance of the data as to that, because at the end of the day you really have to look for the review of lit, and you take it from that some of the recommendations, so as to the relevant or as to the new if you want to go further on that, if you're interested on that, so you can have that. That's how the RRL comes in.
Yes, basically with regard to data, no, the relevance of data does not necessarily entail to whether it's trending or not. Data, at the end of the day, it's still data.
Yeah,
Maybe in the next decade, it won't be trending or it won't be of use, but in the next coming years, maybe in centuries, it could be a revolutionary tool to creating new medications or new formulations and the like. So it
yeah,
data at the end of the day is data. Companies pay millions to get data. And I hope you see the importance of data and being able to manage data.
yeah. When was Newton recognized, or
Mm.
the famous scientists, when they were already dead? Remember that. So just get the data and then publish it. Who knows? One day, some scientists in the NAS is being recognized after how many decades of their data gathering.
Correct. So anyway, that was the last question. Anybody still have any questions? I'd like to remind lang no with regard to the evaluation, please fill out our evaluation forms, and we will be sending the certificates. We know from the previous talks that you weren't able to send because we're still in vacation, but rest assured,
Yeah,
2025 we will be sending your certificates. All of them are ready. However,
kindly remain Khadija and Kisai. Anasrif, if you are there, kindly remain in the Zoom.
oh no!
Yeah.
Charot.
And
Anyway, that concludes our Zoom meeting. We hope that
thank you for
you're
your
able to
questions.
learn.
Thank you for attending this Zoom. Thank you.
Thank you, sir.
Thank you.
Thank you. Thank you, everyone. You may leave the Zoom except Hikadiza and Kisai. Charot. Thank you, everyone. I'll end the Zoom recording.
Yeah.